Mechanics and Properties of Matter, A-Factor Academy, Lagos. So today we'll be looking at mechanics and questions on mechanics and properties of matter. So I've prepared some questions that I would like to share with you, and if you have anything concerning the solved problems, feel free to reach out to me. My links and also comments on whichever part you feel you need more clarification. Thank you. Question number 1. A block of mass 20 kg rests on a horizontal floor. The coefficient of friction is 0.30. But calculate the minimum force required to make the body move when it is pulled at an angle of 60 degrees to the horizontal. So I'll give you a few seconds to look at the questions before we move to the solution part. Solution. Now, you have the horizontal floor. So this is the mass of 20 kilograms. So it's resting on the plane. So this is the mass resting on the plane. Okay. So here is the coefficient of friction. Okay, with respect to the plane. So here we have the weight of the mass acting downward. So let's calculate the weight. The weight is equal to mg. So the mass of the body times the acceleration to gravity. The mass of the body is 20 kg. Okay, acceleration to gravity is 10 meters per second squared. So 20 kilograms times 10 meters per second squared equals 200 newtons. So that's the weight of the body. Now, also we have a force that will oppose this, which is essentially what? Normal reaction. So normal reaction N opposes the weight of the body. So force applied is applied an angle, okay, and the frictional force will oppose this. So the frictional force F sub F will oppose the force applied to pull the body. Now this is the angle of inclination of the what? Of the applied force. So it's inclined at 60 degrees to the what? To the horizontal. Okay. Now let's look at the components of the forces. The force applied. You have the horizontal component, and here is the vertical component. Now here is the detailed interpretation of the question. Now the next thing you have to do now is to solve the problem to see if you can get the force applied to pull the body forward. Now the first thing you have to note is that we should recall that from the law of solid friction, that frictional force depends on normal reaction, so that frictional force will be equal to frictional force will be equal to mu, okay, times n, where n is normal reaction. Okay, so this mu is the coefficient of friction. It could either be mu k, or it could be what? It could be mu s. Okay, mu k is what? Coefficient of kinetic friction, and mu s is what? Coefficient of static or limiting friction. Okay, so now let's go back to what we are discussing. All right, so let's go back to what we are discussing. Now here is the fact that the body is resting on the horizontal plane. Summation of all horizontal components of the forces acting on the body will be equal to 0. Okay, the body is at rest on the surface. Okay, and summation of all vertical forces acting on the body will also be equal to 0. That's the algebraic sum of all the forces. Okay, now the next thing we have to note is that what, from this diagram, if you have to go by this principle, summation f sub x equals to 0 and summation f sub y equals to 0. From the diagram, the f sub x will be equals to the summation of f sub x will be equals to f sub x here going rightward minus f sub f here going leftward, because the body will definitely move in the direction of application of the force. So that means f sub x minus F sub F will equals what 0. And summation of all vertical forces, algebraic sum of all of them will equals 0. That means summation of all forces upward, subtracting summation of all forces downward will equals 0 as well. So forces upward, the N and the what F sub Y, okay, minus the what the weight which is acting downward because it's 0 as well. So from here, that means F sub X equals to what? F sub F, and N, which is normal reaction, equals to the weight minus F sub Y. Now, effective force to move the block forward, which is F sub X equals to F cos theta from resolving this, okay, resolving this, okay. Now, and F sub Y will equals to F sin theta. When you solve this in triangle, okay, we have sin theta is going to, sin 60 degrees is going to be opposite, which is F sub Y over the hypotenuse F, which is the force applied. Okay, F here is the force applied. And cos theta, which is cos 60 degrees equals to adjacent over the hypotenuse, which is F sub X over F. Now, since we have gotten what F sub X is and what F sub Y is, let's look at how to solve the problem. So that when F sub X equals to F sub F, then we can impute the parameters. F sub X is F cos theta equals to what? F sub F, which is what? Mu N. Okay, so mu N, where N is what? W minus F sub Y. So we have all of this. Now the next thing we have to do now is what? Solve further. So we have F cos theta equals to mu times W minus F sin theta. So let's put the parameters now. Including parameters, we have F cos 60 degrees, which is the angle, theta is 60 degrees. Then mu is 0.3 times W, which is 200 Newton minus what? F sin 60. So let's solve this. Cos 60 degrees, okay, is what? 0.5. So 0.5 F equals to 0.3 times 200, 60. 0.3 times F minus F plus minus F sin 60 degrees. That would be 0.3 F sin 60 degrees, which is going to give us 0.5 F equals to 60 minus 0.15 F. Okay, so collecting like terms, so that means minus 0.15 F will go to this to the left hand side. So we have 0.5 F plus 0.15 F equals to 60. So solving this further, we have 0.5 F plus 0.26 F equals 60. So that 0.7 F 76 F equals 60, and F is going to be equals to 60 divided by 0.76, okay, which is going to give us 78.95 Newton, which is going to be approximately equals to 79.0 Newton. So that means the force applied on the body of 20 kilogram to move it forward on this rough surface of coefficient of static friction 0.3 with respect to this body of mass 20 kg is what? 79.0 Newton. Thank you very much and God bless you.